Every product is designed with a specific objective, and so Tableau is designed primarily for data visualization, and which is created by a company called Tableau Software. The beauty of Tableau lies it can connect to nearly any data source. Conventional database, conventional business intelligence tool designed primarily for relational database, semi-structured data source like ERP. You have a structured data source like ERP, enterprise resource planning, customer relationship management, and so on. But the large community of data which are still intact, which Tableau touch, right? Touches your social networking data, right? Data coming from social networking site, cloud-based database. So the beauty of Tableau lies it can connect to any data source and visualize it. So we compare with conventional business intelligence. There's a slogan Tableau follow. Data analytics for everyone. So this tool is not designed primarily for technical users. Even the people who are not good at technology, who know the basic operation of working with computer, they can play with the business data. You don't need to be IT specialist. You don't need to be a data scientist to start visualizing your data. However, with this technical skills, you can make your visualization to the extreme level by doing a predictive analytics modeling, and connect it to your enterprise on big data. You can take your data visualization to the extreme level. But the objective over here, data visualization for everyone. The primary objective over here. The data visualization in Tableau is exceptionally good, and this makes the Tableau ahead of compared to other products. We'll talk about this in detail step by step. Next, I like to compare over here Tableau with conventional BI products. You might have heard of multiple business intelligence product. Their objective is to bring data from disparate sources, different sources, and present data in a meaningful format. This slide first explain you the role where Tableau fit into picture in a conventional data warehousing model. So conventional business intelligence products like your Oracle OBI, Microsoft SSAS, SSRS, reporting tool, Microsoft Business Intelligence tool, IBM Cognos, SAP Business Object. These rules are designed to sit on top of enterprise warehouse. So you have a disparate data sources, operational data source like ERP, CRM, or other data sources, or custom defined data source like sales order processing. You have different data sources. The data is disparate, therefore it is required to put into common place, and this is done through a tool called ETL, extract, transform, and load. Like your product like Informatica, IBM Data Stage, these products are designed to do this data extraction. So data pulled from different sources put into common place, and this term we call enterprise warehouse. It's a one common place of business data across different technologies, across different departments. From different sources we put into common place, and then on top of this we have different tool. We create a OLAP server like Oracle Space, IBM DB2, and then we do reporting. Tableau sit over here in case customer procure Tableau in enterprise warehouse environment. It is sitting on top of enterprise warehouse where we can visualize the data. In addition to this, Tableau is designed to work directly on top of source system because of its in-memory solution. So there are multiple category of customer. The people who are coming from enterprise background, the customer like we can categorize them, the customer enterprise customers. Suppose I'm at a large bank and already has an enterprise warehouse. We have an enterprise data warehouse. Now they already have spent a plenty of money in order to establish this enterprise warehouse. They may be using Tableau for data visualization only. In addition to, they'll have a business intelligence tool like and data visualization. They may be using both. So conventional BI tool they may be using, for example, Oracle OBI, IBM Cognos. Plus, on top of this, they will be using a Tableau for data visualization. Combination of this, because they already spend plenty of money in the infrastructure, they may not feel like spending more money into infrastructure. So Tableau in such case, people can make use of Tableau in memory solution. In memory, as the name indicate, the data stores the memory and give you the power of analyzing data remaining in the memory. Okay, this works in certain scenario. Let's imagine an large enterprise warehouse. We are using a Teradata or Oracle Exalytics. The cost or SAP HANA. These products are designed in memory solution and they are very expensive. They are primarily designed to process data remaining in the source system. So they have a high data processing power. In such case, Tableau just sit on top of that for data visualization. And because these products are designed for high data processing, I can do real-time reporting over here. Real-time reporting. So the customer has to spend little money, just buy the Tableau software which can sit on top of this. We do not require any in-memory solution because my source system is capable enough to process high volume of data, especially when you're working on ERP sources. There are second category of customer who do not have enterprise warehouse data. They have a departmental data and they're low cost, small scale customer, small or mid-size companies, right? They are not IT companies, therefore they don't feel like spending plenty of money in IT. Okay, they have a source data, and my Tableau can sit on top of this. Naturally, the small scale company, so my have a low volume of data. Unlike in this environment where data volume is really high, multiple challenges are there. High volume of data, plus uh, customer need real-time reporting. So source system, my Tableau can sit on top of this. In such case, Tableau make use of, in such example, Tableau can make use of in-memory solution. In-memory solution where you can extract data from source and visualize in Tableau. So extract and visualize. This scenario have a snapshot of data. This is not designed for real-time reporting. It has a snapshot of data. So some transaction happened yesterday. I can see it today. Okay. So when I say data visualization, this is something which we do use in day-to-day life. For example, um, I use YouTube extensively for understanding how people are liking or disliking our videos. Okay. So the report, summary report I have in YouTube video is not real time. It's a snapshot of my data. And look at the line chart of my YouTube channel, who has accessed my videos, for which part of the geography, which country. I could see the line chart, but you see the date. The last data available to me is 15th of July. It is not real time reporting. It's a summarized data, right? So this is a snapshot of data. In case I need a real time reporting, I may be using something else. So there are different category of customer with different needs. If I need a real time reporting, it's a more summary detailed report. I could see my which video who has accessed this, right? So Tableau is designed for both category of customer. For enterprise warehouse where the customer don't need to spend extra money in infrastructure, Tableau can sit on top of the existing infrastructure, right, and give you the power of real time reporting. However, if you have mid-scale, small-size customer, Tableau can sit on top of the source data directly and give you the power of in-memory solution and allow you to do reporting snapshot of data. So the primary keyword over here, data visualization. Right? Data visualization, unlike in old days, is an extreme and multiple ways of data visualization. The conventional business intelligence tool designed to allow you to bring data from source system and present data presentation. The focus was data presentation, but here the focus is data visualization. Data visualization could be simple to could be advanced at multiple level. There are multiple tools are available data visualization. Simple data visualization could be the one I just shown you in YouTube. You can also visualize data using multiple tools. You can simply go to trends.google.com and compare some keywords. This will allow you to understand when you look at the numbers in graphics, it become more easy to understand. For example, I like to compare Tableau versus ClickView. I use two keyword. I like to compare them. Comparing with number versus comparing with graphs and chart make it far easy for me to understand. Okay. With respect to timelines, so you see this is my Tableau, and you see there's I would be able to understand certain patterns. After there's a certain decline every 4 months or 5 months, right? This decline pattern is continue to be happen. This tablet. So comparing two keywords become far easy. Line chart. I can even project is using forecasting, right? The average has been taken the same fashion. The dotted line talk about the forecast for the remaining month. In addition to this, we have got line chart and map. This is a simple way of data visualization. Tableau can do much more than this when it comes to data visualization. The data system focuses the way to present data in a way that it makes sense to the business. In addition to this, another important term is called data exploration, right? Data exploration, if I write in one line, business intelligence designed to answer known question, or business intelligence tool. This like OBI, Cognos, you have a Microsoft BI, okay, SAP Business Object. When you say business intelligence, their focus area to answering known question, whereas Tableau kind of products are designed answering unknown questions. When I say term exploration, exploration means you explore some data, you explore some unknown patterns. When you play around the data, you find some meaningful information, answering unknown question. When I say unknown, when you play around with the data, you would be able to understand some pattern analysis with your data. So this is specialized data exploration. When you talk about conventional reporting tool, right, it consists of three parameters, three component conventional reporting has. First, query tool, as the name indicate, you have a data source over here, you have a reporting layer, and there's a user. So user, in order to get the corporate data, connect to some reporting tool, it's a reporting tool, and bring the required data. So behind the screen, rather than I connect to source system directly, I connect to the reporting tool and it brings the data for me. So behind the screen system render the query. In case I'm using RDBMS, it render SQL query. In case I'm using multidimensional database, it render MDS query. Right? Or in case I'm using semester data source like XML, it render XML query. So tools are responsible to render query and bring the data. Query means bringing data, reporting means presenting them, and in turn analyzing allow you to play around with data to find out certain meaningful information. So some product like IBM Cognos have a separate license for each product component. So from cost point of view also is not feasible. Tableau say we provide you all three capabilities in one tool. You don't need to buy a separate license for query, reporting, analysis. Tableau can give you the power of three component into a single unit. One more thing you need to pay attention: conventional BI tools are designed for IT savvy people, right? We also use a term called self-service business intelligence, self-service, where you don't need any IT support. People can go and just play around with the numbers and get the required information. Tableau designed for next generation data visualization, where IT team focuses only on pure IT activities. Like IT team is responsible to manage data. They're responsible to manage metadata, security permission, server administration, scalability, and software management. But the actual data visualization, playing with the data, is done by non-IT people, the business people. The role has been clearly defined. IT team would be working as a facilitator, whereas business team would be responsible to bring the required data what they need. And this is the one reason many BI project fails in the initial early 90s and 2000 initial, because there was a big gap between the business and the technology people do not understand the business as good as the business people understand. If somebody asks me to work in financial reporting model, it take me long time to understand how business work, and then only I can design a report. So rather than uh, the reportings to be built by technical team, it is to be done by business team itself, and therefore we use the term data analytics for all. This is a conventional model. It is worth to pay attention over here, and where Tableau fit into picture. I already given a little brief about it, but there's a two part of it: the conventional BI solution and new generation data visualization, especially with big data and all new terms you may be hearing of. So in case you're working in enterprise environment, you have a data in disparate location. In case you are working on single source, maybe you have a small grocery shop or a small manufacturing company, and I like to just visualize my business data. I like to understand my customer pattern, finance, my sales order processing, my HR related information. I can connect to my source system directly and do reporting. As a user, my Tableau can connect to the source system directly and give me the insightful information about the business. But this is more challenging when you work in enterprise environment. Your data coming from disparate sources, technology, ERP, customer relationship management, OLAP, or personalized data. People store information into Excel sheet, and the all have to bring it. So first is data source, designing of data source. Then data acquisition, bringing data from disparate sources to common source, which is done by your ETL tool. So conventional data sources are ERP, CRM, and OLAP, but new generation data sources are, you have a data from social networking site. We have data from different source system, mobile devices, your web browser, web applications. You may be surprised to know that 90% of customer survey is being done over social networking site as compared to old days. Social networking site become a big source for business to understand customer behavior, their buying pattern, customer profiling. All is done through social networking site. So new generation BI is not conventional RDBMS. They are social networking sites, and then you need to extract data. In case you're working in data acquisition conventional model, you may be using a product like Informatica and IBM data stage, but some companies are working on open source and the volume data is very really high, and you're working on big data environments commercial corresponding to commercial data acquisition tool like Informatica, and all people can use these products: Spark, Scoop, and Flume. I'm just trying to compare new generation solution. Enterprise warehouse are built in a conventional model like Teradata, and similar product. Oracle also allow to prepare in data warehousing, but the big data solution, when your data coming from disparate sources, your HDFC, your Cassandra, and all, HBase work as data warehousing solution as a repository, and the BI is done in conventional commercial product like Cognos, uh, OBI and all. But in case you're working on big data layer, you may use this multiple product from BI. Many of them are open source. So open source is like your open sky. You can modify, change, integrate anything you want. And you see clearly over here there are two layers. Data analysis and visualization are considered to be two layer, right? Some people, some company put this Tableau under only data visualization reporting. Some company put them in between data visualization and data analysis. Tableau can also be used for data analysis purpose. But essentially, a broader overview about the customer, Tableau is designed for data visualization for small to mid scale companies. Tableau is not being accepted exceptionally. I mean, has not been accepted so far as an enterprise reporting. It is gradually it is going to happen. So if you look at the customer profiling, most of the customer are using Tableau for departmental reporting and all. The new trend has come, which is still emerging. Tableau used for data visualization of big data sources. So this is what I wanted to demonstrate you the difference between conventional BI reporting and Tableau role in enterprise warehouse. In three simple line, where does it fit into picture? The technology future is going to be you process your data, high volume data. Now remember, not all companies need a big data. There's a big hype also. Big data is not needed by all companies, right? So this is one exception when the organization has to deal with really high volume of data. That could be technology future for them. There are three layers: process, analyze, and report. For processing, we use tool Hadoop and Spark. Analyze, you can use, if you compare over here, analyze, you have a product like Teradata, Pestro, and all, and reporting. Tableau fit into reporting layer. Tableau use along, so in case you're planning to have your career in Tableau, you need to equip yourself Tableau in addition to other product. In addition to multiple beauty of Tableaus, there are some exceptional good properties. This is called blending. See, ETL cost very high, okay, and as we discussed over here, in case you have multiple sources, I need to extract data from disparate sources and prepare a common layer. It is possible under certain circumstances. Tableau can sit on top of multiple data sources simultaneously. So I can have two data sources and I can display data in a one uniform way to the customer as if data is coming from single source. This term is started with a term it used to call data fragmentation in the old days, and in many tools like uh, OBI call this, in Tableau we call this data blending. Data blending gives a great power to the customer to connect multiple sources simultaneously and give it to the user as if it comes from single source. I show you live example of this. Here in this example it is shown my business require data from two sources. We have enterprise warehouse, and in addition to this we have got multiple enterprise warehouse. It may possible you have enterprise warehouse plus you have a personalized data which store in Excel sheet. So both ways are possible, data coming from disparate sources. We join them in a way that it looks to the user as if coming from single source. So for me as a customer, it appears data is coming from single source, and we visualize them prudently but come from multiple sources. So you can merge multiple sources without or with the minimum need of ETL, which further lower down the cost of my uh, data. So data blending is absolutely possible and greatly used without compromising with the performance. I'll show you a couple of more slides and I take you directly live. It's good you know about the better, the more you know about the good it is, and especially you compare with other product. Okay, I just now spoke about a concept called in memory. You bring your data into memory and then you process, which makes this very fast. But in memory has two possibilities. In case customer needs a real time reporting, in memory does not work. Real time reporting, right? So real time reporting, as it means the moment transaction happen, we need a we would like to build a report on top of this. But the another category of people who need a snapshot of data, snapshot of data they may not need a real-time reporting. For them, in-memory solution is the best. So this example show two ways. Direct connect to data source. Whatever data source you're using, Tableau can connect to that and give you real-time reporting, right? So the moment transaction happen, it is can be visible to the user. But this is subject to the processing power of your underlying source system, right? If I'm using Oracle, you're expecting real-time reporting, which may not be so efficient. However, if I'm using SAP HANA and you're looking for real-time reporting, it would be exceptionally good. So it's subject to the underlying source system, the processing engine you're using for real-time reporting, right? If you have a small volume of data, you may go for real-time reporting, or you have a processing engine which is designed to manage high volume data. Real-time reporting work perfect. On the other hand, in-memory solution work best for the small scale of data, right? And where I already have invested huge money in my infrastructure, Tableau work as a presentation layer. It bring extracts the data extract you call, and then you present it. So data is a snapshot, not the real data. In conventional term, we used to call this materialized view, right? Materialized view, and in Tableau context we call them extract. So these are the terms are used in the old days as well, but there were different terminologies are being used. um, I also like to explore one of the greatest feature of Tableau, uh, Tableau data visualization. But new generation data also requires statistical analytics, predictive modeling and all, right? The time, so we further key note down the keywords. We need a data presentation, right? We need data visualization, we need data exploration, and then we also need predictive modeling, predictive analytics. We need advanced forecasting data, we need a statistical analytics and finding out some unknown pattern. So Tableau can do these 3-4 jobs: data presentation, visualization, exploration. For predictive analytics, forecasting and statistic modeling, Tableau is not designed. So when your customer needs this information, this piece of data, we use some commercial, non-commercial product which are going to learn in programming, like R programming. Through R programming, you can do very advanced predictive analytics. You can do forecasting and statistical analytics as well. You can also use commercial product like IBM SPSS, or you can use a product like SAS. So when the capabilities of Tableau ends, if you need a predictive modeling and all, the common trend is people are using R programming for predictive modeling, advanced forecasting and statistical analytics. This diagram shows the same. If you see the focus area of this diagram, I have a data analyst. It's not data scientist, data analyst connect to my Tableau server and visualizing the data, right? But who is processing the data? The data processing done by different commercial product like Python, R, SAS, IBM SPSS, which is working on my enterprise data source and processing data and data visualization done through Tableau. I may have some other product in addition to Tableau for data analytics and predictive modeling. Right? So it also works in a scenario where customer need a very highly advanced data analytics. Let's have little hands-on overview of Tableau. I also like to highlight last point over here, which really excites you. When I use a term called data, Tableau can connect to any data source. It really mean any. Okay, and We can divide the data sources conventionally. The data sources conventionally could be relational database, could be multidimensional database, or could be semi-structured data source like flat file and all. This is conventional conventional data sources. New generation data sources, like we have a cloud based data sources, like many vendors are there, like Amazon has Redshift. We have a cloud based application like Salesforce, well known, uh, adaptive analytics. There are many vendors providing cloud based analytics. So Tableau is designed to connect to any data source. In addition to this, we can use the enterprise data warehouse systems like uh, Teradata, SAP HANA, and all. So the beauty is Tableau can sit on top of any data source. When I use term any, it really mean any. Okay. You can categorize this like cloud-based data sources, big data, Hadoop and all, conventional Google Analytics, Google BigQuery, conventional RDBMS, desktop-based databases like semi-structured data sources, Excel and all. So there are multiple Tableau can connect to multiple sources at one time. Now let's see little hands-on activity of Tableau. I already have a data visualization tool over here. I installed Tableau Desktop. We would be learning Tableau Desktop and server both. Okay. So Tableau available for 14 days evaluation edition. You can install this multiple time in your virtual machine and use it. I'm going to show you over here a simple example of how data blending is done with multiple data sources. So this is a simple example where we would be using semi-structured data like I'm using Excel, which has world mobile. I've taken this data from user population, and we'll use some structured data source. I have RDBMS, Oracle. We join them in a way that it looks to the customer the data source is coming from single. Okay. The first thing you should see about Tableau, it can connect to any data source. This is the first screen when you start your Tableau desktop. When you start your Tableau desktop, the first home page talk about I'm using evaluation edition. Connect to file system like Excel, text file, statistical file, and to server. And you see the list of the data sources. It can connect to almost all the data sources. SAP HANA, Salesforce, PostgreSQL, and all. Right. So we'll use two data sources. I'll connect to my Excel, and we do data blending and a small data visualization. So one source I connect to Excel. The moment I connect to this, you see, the beauty of Tableau is that it automatically recognizes the data type, right? And you see the symbol, some icon, this represents the type of data. So you see country is considered as a geographical entity, right? Country, province, city is considered geography, and system give you power to prepare map on top of this. Hatch represents facts or measures or the number. ABC represents your string, and in addition to this you have a date also, but in my source system there is no date. So this is your simple source data, right? This is one data. I can add more data sources. There's an option called plus. I'm doing data blending. One data coming from flat file, another piece of data coming from Oracle. So I give a required information about Oracle. I stored Oracle server over here itself. So I pass required information like server name, service, port number and all. Then I give a credential. Because in my case, uh, as such, model is a super user, is an administrator. Okay. Seems some difficulty connecting anyways. I'm unable to connect data source as of now, but you can click on plus and the same way you can connect to multiple data sources simultaneously. Once you connect to multiple data sources, you have the feel, look and feel given over here same as you have Excel sheet. People coming from Excel sheet background, they are more comfortable in data visualization in Excel. They can see the sheets and we call a term called workbook. And you have a two sources over here in this case. Right now my one source has some difficulty connecting, so I've got two data source, but you can see blending of data. Multiple data sources might display simultaneously, right? On the left side, the system prudently divide this information into two pieces: dimension and your facts or the measure. Automatically they tag them. So data visualization is more like how much you understand about your business information. You drag and drop your information over here. Like example, I drag and drop country, then because system recognize a country type, I can further automatically drill down. It give me power to drill down from country, province, subject to the nature of data you have. Okay. And you can drag and drop your measures over here. The same information we can present in multiple ways. Conventional data presentation using chart, bar chart, line chart, stack chart, isn't it? In addition to this, we can use multiple ways of data present like box chart, right? Box and whistle plot chart, your bubble chart. So the bigger the bubble, the more user or the more major associated with this. When I move my mouse cursor, I could see this is basically a country and mobile users. I could see India has more mobile users. Right? So you have a multiple ways of presenting data. Because I use a country, it give me power to visualize data in terms of charts and map as well. Right? It's partially loaded. I can add number of mobile users over here as a measure and see the numbers over here as well. Number of mobile user versus population, isn't it? So multiple ways are given over here to visualize the same information. Same data you can visualize in multiple format. In addition to this, it also give you power to analyze data trending. You can perform trend analysis, forecasting, trend analysis. Some of them are gray out because I don't have a required piece of data. Therefore, forecasting and trend lines are not available over here. So without especially into IT, you can do this. Your technical, semi-technical user can do this. But when it requires for advanced data visualization, like data forecasting, predictive analytics, and something which is beyond Tableau capabilities can still be achieved by using connective without programming. So that's a very brief visualization of this. We have a set of video tutorials to help people understand Tableau capabilities. You can subscribe to my YouTube channel and get insightful information about Tableau as well. In addition to this, the objective was to give you a very high level overview about Tableau and where does it fit into picture. If you would like to know a little more about it, you can dig it more. We have a information about Tableau hands-on, introduction of Tableau, grouping, how dimension modeling is done, how to connect with Salesforce, BigQuery and all. Okay, you can browse through them in your free time. So that was a brief introduction about Tableau. Finally, the presentation is designed. The objective of webinar is to make people aware about Tableau product and our training program. Our training program uh, for Tableau consists of these modules. In case you have got no experience in business intelligence and data warehousing, yes, we'll cover that. For them, we'll talk about in module 1, we'll talk about business intelligence, data warehousing, and dimension modeling concept. There would be first module, the self-paced learning. It's close to 10 hours of input you need. Okay. And module second, we'll talk about Tableau. Tableau will work in two fold. We'll talk about Tableau desktop and Tableau server. And in Tableau server, I'll talk about administration part. So here we talk about more like a developer activities, developer job, and here I'll talk about admin activities, server administration, security, performance tuning, log navigation, and all. We'll talk about over here. Module third, we'll talk about some integration activities, integration part, right, with R, like with R programming and all. An example. In addition to this, we have a self-paced learning. We would recommend people to go for the self-paced learning. In case you like to explore in statistical analytics, we have a statistical analytics videos will provide you self-paced learning. You can learn statistical analytic basics in Excel sheet, and once you know the concept, you can implement the same in Tableau. So statistical analytics basics will be taught, and if you have no programming experience, with we'll talk about our programming basics and visualization, right? So that would be, it'll give you 360-degree overview about the training program. So you can work as independent consultant in Tableau, right? You will have a specialist skills, R programming, which you would be knowing along with Tableau and statistical analytics. So that's a summary of the training program. Total duration would be close 25 hours, live classes, plus you have a self-paced learning stuff with some hands-on case studies, plus case studies. You need close to 20 hours of input. We have got very structured case studies with business data, design document, and all, how it work in real-time scenario. Okay. So that's the duration of it. Timing would be 60-minute session 25 session of 60-minute session, Monday to Saturday, 60-minute session. My time would be 6 a.m. 8:30 p.m. IST, right? All the learning material we give it to you. We are market leader in data analytics, and I personally have close to 14 years of experience in data analytics and visualization. So all material will provide you, all learning material, a student guide. Okay, will give you hands-on guide and case studies. It is not, it is our own copyright material. Okay, and we give you sample data where you play around with this. Okay, and business design document, requirement sheet, template, wireframe. We have got very structured way of learning. There you can find the requirement sheet, something like this, step by step requirement sheet, business requirement document, requirement 1, data visualization, dimension modeling in case you're using RDBMS, how the model look like, hierarchy, database connection. So requirement by requirement, when you do hands-on on your own, you will feel comfortable. So that's all would be part of this, right? How to install it? So we give you a practice environment. We give you a virtual machine, pre-built virtual machine. Okay, you don't need to do anything, you just need to download it and unzip, that's it. And this is pre-configure with Tableau plus database. Okay, plus integration, you've got integration components. So we minimize your efforts and you only confine to download and unzip, that's it. So in case you are looking for a placement assistance, we have a placement assistance service in US. We have a complete staffing services. So you can speak to me in personal. I can redirect your query to my staffing team. They'll help you in placement assistant in US. That's a brief about the training program and Tableau. I open for your question if you have any.